Hello, everyone. At this time, I'd like to welcome our guest, Robin Frisch-Gleason, who is here today to talk to us about climate change. Robin is a retired public school teacher and geologist, having worked in Antarctica on 3 separate expeditions on topics ranging from field geology to climate change. While she fell in love with Antarctica, she became ever more committed to sharing her experiences from extreme parts of the Earth, first and foremost being the need to preserve and protect the Antarctic environment. Most recently, Robin was trained by former Vice President Al Gore to be a speaker for Climate Reality, an organization whose purpose is to educate the public and inspire action on climate change. Having given 2 previous presentations for the Ann Arbor District Library, Robin is delighted to return to talk to us about climate change. Welcome, Robin.
Thank you so much. Hello, everyone. I'm delighted to be here today to talk to you about climate change. This talk is specifically for students to help you understand what climate change is and how it's impacting our Earth. So I'm really thrilled to be here, and I'm going to jump right into the presentation. I always love to start with this picture of our planet Earth, the 3rd planet from the sun. And it's an incredibly special planet that we live on. It is, as far as we know, the only planet in our solar system that has any life on it. And it is the perfect situation for life to have evolved and to be sustained. The perfect temperature, the fact that we have liquid water on our planet, and it is our shared home. This planet is the home that we all share, all of humanity shares, and all species of animal and plant, every organism on Earth, we share this planet with. And really, this is when we talk about climate change, we're talking about the health of our planet. So it's important to start with an image of the blue marble, the planet that we live on. I want to share some images of my very favorites on Earth, my favorite animals, some of my favorite plants, and some of my favorite places, because we share our planet with these. Orangutans, they live in Asia, in Indonesia, and they live in the rainforests, which are really vulnerable to the changes in our climate. Polar bears, I know some of you have favorite stuffed animal polar bears. They're some of my favorites too, and they live in the Arctic, and they depend on living on sea ice because they need to hunt in the oceans. They dive off of the sea ice and they hunt seals, and then they climb back onto the sea ice to rest and to eat their food, and they really need the sea ice in order to survive. Antarctica is a very favorite place of mine, and on the continent of Antarctica, there are many different kinds of penguins. This is a picture of me on one of my expeditions to Antarctica with Gen 2 penguins in the background. And they too, they need the ice of Antarctica to be able to survive because they get their food source from underneath the sea ice. Sea turtles, this is a picture of a green sea turtle, is one of my favorites. Kangaroos that live in Australia are among my favorite animals as well. And whales, all kinds of whales are my favorites. These happen to be humpbacks, and this is a reminder to us that many organisms really depend on the world oceans for their food and for their safety and for migration. And these are some beautiful, majestic animals. I think you'd agree with me on that. Some of my favorite plants on Earth are in the rainforests. The rainforests are such an incredibly important habitat and biota on our planet because they produce so much of the oxygen that we humans and other animals need in order to breathe. They also take up a lot of the carbon dioxide that we produce, and they are like the lungs of our planet. So I think rainforests are incredibly magical places. I also love meadows full of wildflowers. This is an image on the left. This is a picture of Mount Rainier in the state of Washington, and the meadow is covered with all different kinds of wildflowers. And the picture on the right is a photo of saguaro cacti that are in the Sonoran Desert of Arizona, where I used to live. And I'm just amazed by all these different habitats on Earth and the different plants and animals that occupy those different habitats. And some of my favorite places, as I mentioned, Antarctica is a real favorite place of mine. Antarctica is at the very bottom, the southern part of our globe, and it covers the South Pole, and it's 98% covered by ice and snow. And it's a magnificent, magnificent place. And there's a lot of ice of different forms, and I'll talk about some of that a little bit later in the talk. And I also love really tropical places like Hawaii. This is a picture of a beach in Hawaii, and it's where the land meets the sea. And we'll talk about what's happening with the changing sea level as we get more into climate change. So the gist of climate change is captured in this little slide here. The Earth gets its heat from the sun. Solar radiation from the sun hits our Earth in the form of light waves. And fortunately, we're at the perfect distance from the sun where we get plenty of heat and not too much heat from the sun, and it warms our planet and it makes it very habitable. As the heat reaches the Earth, there is some heat that's reflected in the form of infrared radiation, and it bounces off the Earth and it escapes back into the atmosphere. And that's all perfect. That's been the case for billions of years on Earth, although it is beginning to change. Some of the infrared radiation is actually trapped by our atmosphere. Now, our atmosphere is a thin layer of gas that's just above the Earth, and it filters some of the light coming into our Earth, and it traps some of this infrared radiation that is trying to escape from the Earth. And as human activities create different kinds of gases, it actually thickens this layer above the Earth. It thickens our atmosphere and it traps more and more radiation. And that trapping of radiation is what's causing the Earth to warm. That's causing what we call global warming or climate change. Why does that happen? Well, human activities are creating gases. In fact, about 150 million tons of man-made gases into that thin shell of an atmosphere every single day. We're treating it as though it's an open sewer. And that is having an effect on our atmosphere. It's thickening our atmosphere, it's trapping gases, and it's making our planet warmer. It's behaving as though it's a greenhouse. So you've probably all seen greenhouses before, made of glass, and the heat comes in and it's trapped by the glass that the greenhouse is made out of. And the plants inside the greenhouse love that additional heat, and they thrive with that additional heat. But humans don't always thrive with the additional heat, and it's making conditions change on Earth. But I want to point out that there's a big difference between weather and climate. Weather is something that happens on an individual day. Like maybe a few days ago, it was chilly outside. That was a chilly day. The weather was chilly. Or maybe tomorrow it's going to rain. That is weather. That is a single day event. Climate is different. Climate is a long-term trend. So when we talk about climate change on Earth, we're not talking about one day it's hotter or one winter it's colder. We're talking about long-term trends over a period of years that's happening all over the Earth. We collect weather data all over the Earth on every day, multiple times a day. And when we see averages changing, that means that we are having a change in our global climate. So climate is what we're talking about here, not so much weather. So I don't want to get too far into these different gases, but I do want to make sure that you know one gas in particular, carbon dioxide. That is, if you hold your hand in front of your mouth and you breathe out, a lot of that gas coming out of your lungs, out of your mouth, is carbon dioxide. That is a gas that we breathe out, but it's also a gas that's produced by cars when we drive, and by airplanes, and by manufacturing. And those sources of carbon dioxide are having an impact on our global climate because they're impacting that shell of atmosphere over our heads. Methane is another gas that's really important in our atmosphere that's trapping these this infrared radiation. Methane is another key player in global climate change. So this diagram, it's a very busy diagram, but what it's showing are the biggest sources of these gases that are causing the Earth to warm. In other words, the greenhouse gases. And I want to point out just a few of these because they're really important players in global climate change. Any kind of transportation right now is using a lot of fuel. That fuel are things like petroleum and gasoline. Cars use gasoline, trucks, buses, airplanes use a lot of gasoline. These are called fossil fuels. They're called fossil fuels because it's literally oil that is in the ground that formed at the time of the dinosaurs. This oil formed from plants that were growing hundreds of millions of years ago, and the plants died and they became buried and they decomposed, and over time they turned into oil. So humans have extracted or pulled that oil out of the ground, or pulled coal out of the ground. That's another fossil fuel, and we burn it. And in the process of burning, we get energy to fly our planes, to drive our cars, to drive our buses. But in the process of burning those fossil fuels, we produce a lot of carbon dioxide. So that's a really big source of carbon dioxide in our atmosphere. Landfills are another important source. So when you throw something in the trash, it gets collected by the garbage trucks and thrown into a landfill. Well, we think of it as being gone forever, but it's not gone forever. It starts decomposing, and in the process of decomposing, it creates a gas called methane. Methane is another of these greenhouse gases that go up into the atmosphere and contribute to global warming. Industry, like factories, they produce a lot of greenhouse gases. Another thing that you may not think of as being an important player in climate change, but it's agriculture, cows in particular. Now, if you drink cow's milk or if you eat beef, they are produced on farms, and cows, after they eat, they burp a lot, and their burps contain a lot of methane, a huge amount of methane, actually. So agriculture contributes 25% of our greenhouse gases on our planet. So all of these things and more contribute to climate change. One more that I have to bring up, and that is the burning of our forests. This is hugely important because remember when I showed a picture of the rainforest, I said these are like the lungs of our earth. Well, rainforests, all forests actually, not only produce oxygen for us to breathe that we need, but they absorb carbon dioxide. They take up the carbon dioxide. So instead of allowing it to go up into the atmosphere, they absorb some of it and they use it in the growing process. But when we burn our forests, not only are we destroying that source of oxygen, but we're also destroying the sink, the thing that absorbs carbon dioxide. So it's a double whammy, and burning our forests is really bad for the planet. So I want to show some graphs, and I don't want to get too technical, but I'm going to just tell you the gist, the most important ideas of the graphs. This is a graph just showing how fossil fuels have created global warming and how it's changed over time. So this is billions of metric tons of carbon, basically the amount of carbon dioxide in our atmosphere. In the year 1850, there was a very small amount because we didn't have many cars and we didn't have much industry. But as we go forward in time, here's 1950, after the invention of cars and manufacturing factories and so forth, we have more and more carbon dioxide. And look, by the year 2019, it's way, way up high because we have so much more carbon dioxide caused by human activities. This increase in greenhouse gases is causing higher temperatures. There are temperatures on the Earth that in some places it's reaching 124 degrees Fahrenheit. That is really, really hot. There are people getting sick. There are even people dying as a result of temperatures this warm. And it's not just humans that are suffering. A lot of animals and plants are either dying off or they're having to migrate to different places on the Earth because it's getting too warm where they live. Now, a lot of the heat that reaches Earth, a lot of the excess heat that's reaching the Earth goes into our oceans. 3/4 of our planet is covered by ocean. So a lot of that excess heat is going into the ocean. In fact, 93% is going into the world's oceans. And this too, it's a complicated graph, but what I want to show you here is this, the bottom axis is time. So in 1960, there was some additional heat reaching the oceans, and this lightest color is the surface down to about 300 meters. The middle blue is down to 700 meters. And then the darker the shade, the deeper the depth in the ocean. But if we look here to 2020, look how much additional heat content is reaching the ocean. So much more heat is getting absorbed by the oceans. In fact, half of the heat that is going into the oceans, half of the increase in the heat has happened since about the year 2002. So in the last 20 or so years, we've doubled the amount of excess heat in our oceans. That excess heat is a lot of excess moisture and a lot of excess energy. So with all of this extra moisture and energy, we're fueling bigger and bigger storms. So I'm sure you've heard about hurricanes and typhoons and cyclones all over the world. These are getting bigger and more powerful, and they're getting more frequent as time goes on. Why? Because there's a thicker atmosphere that's trapping more heat, that's warming the oceans, and it's causing bigger and bigger hurricanes, typhoons, and cyclones. And these do a lot of damage. So I know you've all heard of the hydrological cycle, or at least heard that term. The hydrological cycle is really the story of water and how it behaves on Earth. So here's a picture of our Earth, and we have evaporation happening. Evaporation happens when there's warm energy and the water of the ocean or lakes or rivers evaporates and turns into gas. That becomes clouds. Clouds eventually move over land and it falls. It falls in the form of rain or snow or sleet or hail. It can also fall over water as well. But when rain falls on land, especially in a really large rain event, such as a hurricane, it can cause flooding. It can flood cities. It can break dams that are holding back water along rivers. It can even fall into contaminated areas and flood contaminated sites and spread contamination around. Now, eventually, all of that precipitation, that rain, will flow into streams, into rivers, and it will work its way back into the oceans. And then that cycle starts all over again. This is the hydrological cycle. With extreme rain events, we get flooding that looks like this. So these are houses that are completely buried by water due to a really big rain event. You can even see vehicles stranded on this bridge that's out of water, but the rest of the road is underwater. So these flood events can do a huge amount of damage. Now, you may think that, wow, all that rain is good in a way because then we don't have really dry areas on Earth. But that's not really the case, because that same extra heat that evaporates water from the ocean and causes really big downpours and floods, that heat also pulls moisture even more quickly from the soil, causing longer and deeper droughts. So a drought is an area that has had no or very little rain for a long period of time. So with this extra rainfall, it doesn't get equally distributed around the Earth. We get droughts in some areas and we get flooding in other areas. This is an area of Brazil that used to be a water reservoir, but now it's all dried out, almost all dried out. There's very little water left. So this is another consequence of global climate change or global warming. So think about how the climate is changing and what it's going to do to some of my favorite plants. And you have favorite plants too, I'm sure. These wildflowers on the flanks of Mount Rainier, or these cacti in the Sonoran Desert. As the climate changes, so do all of these habitats, and so do all the animals that live in these habitats. With hotter years that typically have more drought, we also have more fires. So this chart shows that as temperature increases, we also get an increase in fires. This is in the Western United States. Now, in the last 50 or so years, the length of the wildfire season in the Western United States has increased 100 days per year. So it's now 100 days longer per year than it was about 50 years ago. And these fires are really damaging. We have them throughout the United States. The rest of the world is having them too. Back in 2019, there were horrendous fires in Australia. And as I'm sure you know, kangaroos live in Australia. And many, many animals were killed. I've read that they estimate 1 billion animals were killed by the fires in Australia. So these dry conditions are really dangerous for animals. This is a glacier in Greenland. Now that's up in the Arctic. And as we get an increase in global temperature, the ice on our planet is melting more and more. So that glacier, which is a river of ice, is now completely melted. And glaciers, once they melt, all that water flows into the oceans. So this is a graph showing the amount of, or the change in the amount of ice from 2002 to the present. There's a steep decline in the amount of ice in Greenland and elsewhere on the Earth. What does that do to polar bears? You know, polar bears need ice in order to survive. Now, they are on sea ice, and the previous picture was a picture of glaciers, which are on land, but sea ice and glacial ice is melting worldwide. And here's Antarctica again. It's magnificent and it's beautiful, and ice is starting to melt in a big way. And we need to be thinking about how that's affecting habitats, water supply, and the level of the world's oceans. Again, I showed pictures of these Gentoo penguins in Antarctica. They're losing their food supply because they depend on sea ice to have organisms living on the underside. That's what they feed on. So if they lose the sea ice, they lose their food supply. As all of this water melts, it goes into the world's oceans. The world's oceans have increased about 10 inches per year. 10 inches. The world's oceans have increased about 10 inches in the last 100 years. That means sea level has risen 10 inches. So in places like Miami Beach, Florida, that are very close to sea level, they are flooding the cities at times when there's a high tide. So Miami Beach, I know some of you have probably been to Miami Beach. This is Miami Beach on a sunny day. It's a sunny day. There's no rain coming down, but it's the sea level is high enough that at certain points of the month, there are extremely high tides. And this is an extremely high tide, and it's flooding the streets of Florida when there's not even a rainfall. I'm going to see if I can play this video again just to show you the streets of Miami Beach due to rising sea level. Sometimes there are octopus or fish found on the streets of Miami Beach because this is ocean water that's just flowing into the streets. Now that's with a 10-inch rise in sea level globally. If we don't change our ways, sea level is going to rise higher, and then we will have higher and higher sea level that's going to flood much more significantly and will flood a lot more areas of the earth. In fact, this is a projection that if we don't do things to change how much gas is in our atmosphere, this is what Miami Beach could look like in the year 2050. That's just or a little more than 30 years from now. You can see a lot of areas flooded. This would cost a lot of damage. It would make a lot of people have to move away from Miami Beach. And again, this beautiful picture of a beach in Hawaii, if the sea level goes up, we're going to not have much beach left in Hawaii and other beaches around the world. Another consequence of climate change is that we get carbon dioxide dissolving in the world oceans, and that creates an acid called nitric acid, and that is causing a lot of damage. It's killing coral reefs, which many organisms depend on. A lot of fish live in coral reefs. And in the last 30 years, the Great Barrier Reef, which is a really large and impressive coral reef in Australia, has lost half of its coral cover because of the increase in ocean temperatures, resulting in increased acidity of the oceans. What does that do to the sea tortoises and the whales and the other animals that live in the oceans? I know you can imagine it does a lot of damage. This is a picture of an Indonesian, what used to be an Indonesian rainforest, and those have been cut down to grow palm trees. Palm trees are used to get palm oil, which is a product used in, believe it or not, a lot of baked goods, things like cookies and cakes, as well as shampoos and lotions. And it's an important product, and they make a lot of money from selling palm oil, but they're cutting down the rainforest to grow the palm trees. And the palm trees don't have the same benefits of absorbing carbon dioxide, of absorbing carbon dioxide and giving off oxygen. So by buying products that have palm oil, we are supporting this industry that's causing the rainforests to be cut down. These are being cut at a rate of about 1 football field sized area every second. And the orangutans live in this area, so their habitat is getting severely diminished. We are now at risk of losing about half of all land-based species in this century if we don't do something. So the cost of carbon is huge. And I haven't talked about all these things, and a lot of these are sort of adult issues, but they are things that we're really dealing with. We've talked about the loss of ecosystems. We've talked about sea level rise. We've talked about drought and wildfires and damage from storms and mudslides and floods. So there's a lot of damage that's happening because of increased gases in our atmosphere. So I know that's all kind of depressing, but I don't want you to lose hope. Must we change? I know you would agree with me that we must change. Change must happen. Can we change? This is where the hopeful part comes in. Yes, we can change. We have the solutions right now to make big changes on our planet. Wind energy. This is a great answer to global climate change. When we build wind turbines, we can harness the wind's energy and turn it into electricity for businesses, for electric cars, for homes, for everything that uses energy. Instead of burning fossil fuels, we can use wind energy. Since 1980, look at how our use of wind energy has increased. This actually shows our capacity. That means how much we can produce. From 1980 till the present, it's just increased dramatically. Globally, wind could supply worldwide electricity consumption 40 times over. The answer is there if we just put in enough windmills to capture the wind's energy. Solar is another really important answer. Solar panels collect the sun's energy and turn it into electricity. The world solar photovoltaic cells installations, that means solar panels, have again, look how we've grown our supply of photovoltaic cells since 1980. That means we can burn less and less fossil fuel and collect energy on photovoltaic cells. We have enough solar energy reaching the Earth every hour to fill all the world's energy needs for an entire year. In 1 hour, enough solar energy reaches the Earth to satisfy the world's needs for a full year. So we can change the future. We can change the future by investing in solar energy, investing in wind energy, and reducing the use of these fossil fuels. Changing our source of lighting, LED lights, which many of you already have in your house. They are being replaced very quickly. In 2010, only 1% of the population used LED lights. In 2025, we estimate that 95% of the world's population will use LED lights, and they are far more efficient than the traditional incandescent light bulbs. And car manufacturers are saying, we want to protect the planet. We're going to start moving towards electric vehicles. These are all the different car companies that are moving to electric vehicles. Electric vehicles, again, they can run on solar energy. They can run on wind energy. They don't need to burn fossil fuels in their engines. So can we change? Yes, we absolutely can change. Will we change? That's the million-dollar question. And I truly believe, and I want you to believe, that we can change. In the year 2015, a very important agreement was signed called the Paris Agreement. And in that agreement, every nation in the world agreed to work together to achieve net zero greenhouse gas emissions. That means we're going to cut our emissions of carbon dioxide and methane to zero by the year 2050. And our president is very committed to making this happen. In addition to our leadership, people are standing up, they're attending rallies, they're attending marches, they're saying, we want a cleaner future. We want to switch our energy source from fossil fuels to renewable energy so that our children and our children's children will have a clean planet. What are things that you can do right now to help the planet and stop producing all of these greenhouse gas emissions? You can carpool. Instead of you and a parent being in a car, you can carpool with other people. You can walk rather than drive when it's possible. You can use reusable bags. When we make plastic, we are using petroleum. That's the oil that comes out of the ground. We're using that to produce plastic. Plastic also pollutes the planet a lot, but the manufacture of plastic is putting greenhouse gases into the atmosphere. If you use reusable bags, we'll use less plastic. So that's an important thing you can do, and impress upon your parents to do that. We can reduce the amount of materials we use. We can reuse whatever materials we do use. And of course, we can recycle. Really important. Part of recycling means passing clothes and toys onto younger kids. Instead of going out and buying new things, which use more materials and more energy to produce, we can pass things on. So more things don't have to be manufactured, or fewer of them do. Composting food waste. So instead of throwing excess food or wasted food into the trash, number one, we should stop wasting food. And number two, put food remains in the compost and apply it to gardens, because that way our gardens grow better and they will help diminish carbon dioxide. Grow a vegetable garden. Get your food right from your own backyard. Get your food locally. You know, it doesn't make any sense to go to a grocery store to buy apples that were grown in New Zealand that have to fly on an airplane to come to Michigan. If we can buy food locally, then we're not paying all those transportation costs and all of those emissions of transportation for us to eat our food. Eat less meat, drink less cow's milk if possible, because the manufacture of beef and milk produces a lot of methane. Turn off the water and the lights when not in use. That's just energy and resources that are being wasted. Avoid using throwaway plastic, such as plastic silverware. Use reusable things so we don't have the waste and we don't have the manufacture. Adjust your thermostat. It can be a little cooler in the winter and it can be a little warmer in your house in the summer. And make sure that windows are not open when you have the air conditioner on or the heater on. You can bike to school rather than drive. Use less fossil fuel. Use reusable bottles, water bottles, instead of plastic. Use your voice. Use your voice to write letters to the school district or to the city of Ann Arbor, or if you live in a different city, write to that city, or the state leadership or the federal government. Use your voice in marches to say, we want our leadership to switch to green energy and protect the future for the people and the plants and animals that we share the planet with. Plant trees, because we all know that trees do good things for our planet. Be a voice to protect the earth, because our world depends on it. So I want to thank you for being part of this global conversation, and I welcome your questions. You can email me at this address down here, robingleason0@gmail.com. I'm a member of an organization called Climate Reality, and Climate Reality Project, the website is right here, and there's a lot of great resources on that website. So I encourage you to go there as well. But if you have questions, I would be delighted to answer them. And I thank you for joining me today.